and transit engineers have been given the go-ahead. They have joined forces to lift Toronto out of a morass of traffic congestion. The basic principle of their plan is separation of motor vehicle traffic and railed traffic. The city's planning engineers push forward with more and wider motor thoroughfares, and the transit engineers bring within early realization high-speed subways and off-the-street rapid transit rights-of-way, healthy arteries to carry the lifeblood of traffic, of people, to all sections of the city. A famous mayor of New York gave testimony to rapid transit in these words: "New York did not build the subways built New York." With a bow to the sidewalk experts who keep a loving eye on progress and give freely of their time and advice as they supervise the men at work, the TTC rapid transit plans are underway.
Buses are used to carry the street decking. As the decking proceeded, the conduits and the pipes of the utilities were tied with cables and suspended from the beams or trusses. The old main sewer under Yonge Street, which is shown here, replaced by a new trunk sewer under Victoria Street. Two small temporary sewers were installed at the sides of the excavation under Yonge Street. Between stations and at some of the stations, big steel beams were placed to carry the deck because the beams are more quickly installed. Busy intersections like this King and Yonge corner were the stages for some secular giant juggling acts. On these cross members were laid the 12 by 12 timbers, which provided a temporary road surface. When this load of big timbers arrived for unloading at Dundas and Yonge, passers-by expected some strongman acts, but machines did the heavy lifting. Additional steel supports were placed to carry the temporary tracks, which were relayed so that surface traffic and transportation was restored during the remainder of the underground construction. Most of these big 12 by 12 timbers come from British Columbia, some from northern Ontario. The Commission's own track gangs rebuilt the intricate track switches and crossovers at street intersections. This work was scheduled to keep interruption to streetcar services to a minimum. This intersection of Adelaide and Yonge carries a heavy service of Yonge and Bathurst cars. Planking was carefully fitted between the rails to complete the roadway decking. Surface traffic and streetcar service were resumed while construction proceeded below the decking. As the excavation proceeded, 3-inch planks were inserted horizontally between the piles to form the sidewall shoring. To insert these 3-inch planks, the earth was carefully cut back with air spades until the face of the clay was about 3 inches back of the front of the steel pile. Then the plank was slipped in behind the front of the pile, and wedges were driven in between the plank and the pile to press the planks tightly against the clay. With the sides of the cut well retained and surface facilities temporarily restored, the clay between was excavated by power shovels and loaded onto trucks. Ramps were constructed at several points as underground excavation continued, and the excavated material was carried to surface via these ramps. One ramp was on Temperance Street at Yonge. Thousands of yards of excavated material was trucked to spots in the Toronto Harbor, where this fill was very welcome. The subway structure is a concrete box. The floor built first, and then the walls. The structure is heavily reinforced with steel. This concrete station base is 3 feet deep Elsewhere, the base varies between 2 and 3 feet. Preparing for the pouring of the concrete walls and roof, the reinforcing was placed and metal forms were assembled. The concrete used in the subway was delivered ready mixed. When the concrete was delivered to the job, it was poured down through elephant trunks, which can be swung around below the deck to guide the concrete to the proper place in the forms. To consolidate the concrete, an air-driven vibrator removed the air bubbles. Metal form was released and moved 40 feet to be resection of roof. Each 40-foot section contains about 20 tons of steel reinforcing. At stations where the tunnel is wider, there is a row of steel columns supporting the roof. As the subway structure was being completed, the various utilities were relocated. The temporary street decking and supporting girders removed, and the excavation backfilled with sand. Sand was brought from approved pits by truck. The sand was inspected by the Commission's representative. His approval slip had to accompany the load for acceptance on the job. A total of 145,000 tons of sand was required for the backfill. It was hauled from several sand pits near Weston and near Markham. Arriving at the subway job on Yonge Street at Gerrard Street, this sand was dumped onto the completed subway structure. After the street had been filled, the sand was leveled and compacted. Then the car tracks and asphalt pavement were laid and car service resumed. At Alexander Street, the subway moved over to a right-of-way 150 feet east of Yonge Street. From Alexander Street to Ramsden Park, the cut-and-cover type of construction was similar to that already described for the subway south of Alexander Street. One important difference was that here some buildings had to be demolished. Incidentally, after construction has been completed and the space above the subway roof has been refilled to surface level, arrangements may be made for use of the surface for automobile parking. Piles were driven on this off-street construction to keep the sides of the bank back, just as they were used in the construction under Yonge Street. The same size of pile was used, but because no deck had to be carried, they were placed a little farther apart. As the work moved north, the soil conditions changed and the problem of driving piles changed. Nearly all of the soil encountered under Yonge Street was a very hard blue clay. However, farther north, the material changed to beds of clay and sand and very fine grain material. The hill or escarpment just south of St. Clair Avenue is the shoreline of an historic lake, so that along the edge of this lake were found layers of material deposited by water. South of Bloor Street, as the construction proceeded, temporary bridges were built to carry the traffic across construction areas. The Wellesley-Rosedale bus maintained service by using this bridge. At the Wellesley station, where the span was quite wide, the contractor extended the piles and braced them to the center. With the supporting structure and reinforcing in place, the concrete fill was delivered in ready-mix trucks and spouted to the construction below, which brought the Wellesley station up to this point of its development. On Bloor Street, the streetcars were diverted to the side of the street on temporary tracks to permit the construction of the subway to surface transfer station built in the middle of Bloor Street, just east of Yonge. North of Ramsden Park, the rapid transit route will be in an open-cut right-of-way, except where it tunnels under the CPR tracks and under St. Clair Avenue and some buildings on St. Clair and on Yonge. Let's take a look back at the combined bus loop and rapid transit station being prepared in Ramsden Park. The buses will bring Rosedale residents to this loop to transfer to the subway. The trench was required to construct a drainage sewer. A manhole was built in the excavation. In the open-cut construction between Ramsden Park and St. Clair Avenue, the banks are sloped 1 foot vertically to 2 feet horizontally. The pipe in the bottom of the trench down the east side intercepts the street sewers which flow towards Yonge Street. In open-cut sections, to maintain traffic at cross streets during construction, temporary bridges were used. In many cases, Bailey bridges, similar to those used by the Army, were used by the contractor. Permanent bridges to carry surface cross traffic will be the graceful, rigid frame type made of reinforced concrete. The first of these bridges was built at Aylmer Avenue. In many cases, utilities are carried across bridges in a layer of earth on top of the concrete arch beneath the pavement. After the forms were removed, construction of wing walls for the approaches followed. Where the subway crossed under Yonge Street at Heath Street, the full service of the Yonge Street cars continued without interruption. The first diversion of streetcar tracks to the west enabled piling and decking to be constructed on the east side of the street. The tracks were then diverted over this decking and the west side of the street piled and decked. North of Heath Street, the open cut reappears with the side of the cut retained by piles. The earth was excavated between them, just as it was under Yonge Street, but no decking was necessary here. North of the Beltline and to Chaplin Crescent, a broad, shallow excavation was made to accommodate a storage yard for rapid transit cars. A dragline excavator did the heavy work here. In this wide cut, a car maintenance shop, a boiler house, and track maintenance shop will be built. Also, there will be storage tracks. Digging the big hole up at Yonge Street and Chaplin Crescent, down at the Union Station, work was proceeding on the underground passage which will connect the railroad station with the subway. Leaving the railroad station, this passage has to dip under the taxicab driveway on the lower level of the station. To come up to the level of the subway mezzanine, this underground ramp passage turns east and is sloped easily upward until it joins the street entrance outside the post office in an approach to the subway mezzanine. At the Union Station, the 500-foot station platform is in the middle. Arriving subway trains may take positions on either side of the 24-foot platform. A double crossover here will permit the dispatch of subway trains from either side of the station platform to the outgoing tunnel. The distinctive color scheme of the Union Station is in primrose and American red. Underground in the downtown stations, the terrazzo floormen made good progress on the terrazzo finish on top of the concrete station platforms. After the underbed had been spread into position, heavy zinc strips were set to divide the surface terrazzo finish into 2-foot squares. The top finish, to be applied later, consists of cement, marble chips, and an abrasive to help prevent slipping. The walls of the stations are finished in colored glass-faced masonry. Each station has a distinctive color scheme. The colors for the King Station are English eggshell and forest green. Stations are easily recognized as station name signs are repeated on the station walls. Passengers arriving at King Station may take the escalator to the mezzanine. From the mezzanine, there are exits to the 4 surface corners. No need for incoming or outgoing passengers to cross through surface traffic. Outgoing, you just choose the exit which takes you to the surface corner you desire. Incoming, you enter from any of the 4 corners. On the mezzanine, departing passengers will buy tickets and pass through turnstiles leading to the stairs for the track level. The rails in the subway are T-rails, similar to those used on steam railroads. They weigh 100 pounds to the yard. A third rail at the side, not shown in these pictures, will feed electric power to the subway cars. There will be no overhead trolley wires or trolley poles. You will see no wooden or other ties under the subway rails. To minimize noise and vibration, a rubber cushion cemented to a rolled steel plate is bolted directly into the concrete base. The rails are mounted on these plates, which are spaced every 2 feet. All rail lengths are thermit welded together to form a continuous, smooth and quiet rail with no noisy and bumpy joints where rail lengths meet. Here's what Canada's first subway car will look like. It is 2 feet wider than surface streetcars. There is thermostatically controlled electric heating under every seat. Normally, the subway cars will be assembled in 2-car trains with a control booth at one end of each car. This eliminates the necessity of having turning loops. In rush hours, trains may be increased to as many as 8 cars. See how easily and safely passengers walk into and out of the car. And what a time saver, with no steps up or down. Each subway car will have 3 double-width doors, which will open at every station. The seats in the car are grouped around these doors so that no one need ever take more than 5 steps from the farthest seat to the station platform. Every car will be equipped with a route map. A passenger may easily see what station is next and how many stations to his destination. The first structure of the rapid transit service to appear above ground level was the Wellesley Station. The Wellesley-Rosedale buses will loop around this station to permit direct transfer of passengers to and from the subway. On Bloor Street, just east of Yonge Street, passengers will transfer directly between surface streetcar platforms and the subway platforms below without using transfer tickets, and without being exposed to surface street traffic dangers and delays. Northbound, the first open-cut station is the Rosedale Station at Crescent Road in Yonge Street. Below will be 500-foot platforms with reinforced concrete platform covers. Above, the Rosedale buses will load and unload transfer passengers under cover. Here also, no transfer tickets will be needed. In the open-cut sections of the rapid transit line, the ground slopes at the sides were covered with a low-growing green foliaged shrub. There was an interesting engineering project where the subway passes under St. Clair Avenue and under some stores, theaters, and apartment buildings north of St. Clair Avenue, just before the subway swings over to the west side of Yonge Street at Heath Street. Before the excavation for the proceeded, steel beams were placed between these side walls to relieve the strain on them, under the foundations and floors of the buildings above. As excavation and other work were built underneath the floor that carries the seats of the Hollywood Theater. The floor of the theater was carried on steel beams and precast concrete slabs, which were placed while the theater continued to operate. To prevent the carrying of vibrations set up by the moving of subway trains through the subway structure and up the underpinning walls to the theater above, a 3-inch wall of cork insulation was applied between the concrete wall of the subway structure and the concrete underpinning walls. The construction of the subway structure at this point was similar to construction at points further south. There was the heavy steel reinforcing for the concrete base. After the base had been poured and had set, work proceeded on the erection of the steel reinforcing for the concrete walls of the subway structure. In the spring of '52, footings and foundations were sprouting up all over in the big hole south of Chaplin Crescent, where the subway car shops and the Davisville station of the subway combined to make an impressive project. A substantial bridge was built to carry surface vehicular and pedestrian traffic on Chaplin Crescent, immediately west of Yonge Street. Below the bridge are part of the loading platforms of the Davisville station and some sections of the shops. From this bridge, the panorama includes the surface structure of the Davisville Rapid Transit Station on the southwest corner of Yonge and Chaplin, and the driveways and passenger platforms to be used by the Davisville, South Leaside, and Avenue Road buses. Attached to the retaining wall beside the Davisville station platform is an operating signal tower. A passageway from beneath the surface bus station brings passengers to and from the subway passenger platforms. An impressive layout of operating and maintenance shops stretches northward from near the Beltline Railroad to beyond Chaplin Bridge. The more extensive sections of the shops, stretching westward and southward, will contain the repair pits and all modern facilities for the efficient maintenance and repair of the subway trains. Here at Eglinton and Yonge is the northern terminus of the subway, the end of steel, as railroaders would say. North of here, there will be no steel rails. Routes of trolley coaches and gasoline buses will converge on this terminal from west, north, and east. In addition to the passengers served by these TTCs, where the Rapid Transit subway crossed to the west side of Yonge Street, north of Lawton Boulevard, the Alexander Muir Memorial Gardens were moved from the Rapid Transit right-of-way to a new location, fronting on the east side of Yonge Street at St. Edmunds Drive. The new gardens were rededicated to the memory of the author of The Maple Leaf Forever, the late Alexander Muir, patriot, scholar, and composer, on May 28, 1952. Controller Leslie B. Saunders officiated for the city, with Chairman William C. McBrien, Vice Chairman William G. Rutt, and Commissioner Charles A. Walton of the Toronto Transportation Commission present. During the ceremonies, Commissioner Walton presented a souvenir bracelet to little Janice Parsons, granddaughter of Vice Chairman and Mrs. Russell. Janice presented roses to Mrs. William C. McBrien, who unveiled the appropriately worded plaque as the Salvation Army Training College Band played The Maple Leaf Forever. An appropriate prayer of rededication completed the ceremonies. They experienced not only a change of address, but a vastly larger and more attractive layout as the result of being moved by the TTC.